The next phrase I want you to write down on the top of your paper is the argument never changes. Okay, that's a really big phrase. The argument never changes. The argument never changes. The argument never changes. Underline it, highlight it, star it, circle it, bold it, whatever you need to do so you don't forget that phrase. Okay, so when I look at these 4 examples here, we have 5 total. Okay, so these 4, and then I'll put another one up here. All right, so when I look at them, I first figure out what is the argument. Well, if it's written like this, sine of 2x, 2x is my argument. So that means my final answer better have a 2x in it. That 2x is never going to change anywhere in the problem. Okay, so I start out by taking the derivative of sine. Well, the derivative of sine is cosine. The argument doesn't change. Whatever the argument was at the beginning, that's the argument at the end. So that didn't change. The only difference now with the chain rule is that before this section, the argument was always x in every one of your problems. Well, now the argument's going to be different. So you have to take the derivative of that argument. So derivative of sine is cosine. Argument didn't change. What's the derivative of the argument? 2. So put that out front. So that is my answer, 2 cosine of 2x. Done. All right, so let's look at number 2. I have cosine of x minus 1. It's kind of nice because x minus 1 is already in parentheses, so that's already my argument. So that's not going to change. So when I take the derivative, cosine is negative sine. Don't change the argument. It was x minus 1. Keep it x minus 1. Now take the derivative of the inside of the argument. What's the derivative of x minus 1? Well, just 1. So multiply it by 1, and then it doesn't really change anything. So there's your answer. All right, down here in number 3, it's not telling you what the argument is. So I go through and I figure out, okay, 3x is my argument, so that's not going to change. What's the derivative of tangent? Well, on my list here, tangent is secant squared. So I'm going to write secant squared, and I'm not going to change my argument. But now I have to take the derivative of the argument. So derivative of 3x is just 3. So I'm going to sneak a 3 out front. And that is my answer. So kind of the steps I go through is I take the derivative of the trig function, and then I take the derivative of the argument. Okay, now we get into some sneakier ones here. Let's look at number 4. Okay, so number 4, I have a couple things kind of going wrong in this problem. The first is I don't know what the argument is. So I'm going to go through and say, all right, well, 4x is my argument. The other problem is this 3. I have a hard time taking derivatives when the 3 is there. So I'm going to go through and I'm going to change this around to be the sine of 4x, but that it's really 3 of them. So I'm going to put brackets, and I'm going to move that 3 to the whole outside. Notice that the 3 now encompasses the entire thing. Okay, so now I'm going to take the derivative. So my derivative, I'm going to power down just like we did yesterday. Okay, power down, the 3 goes out front. I'm going to rewrite this whole entire thing. Nothing changed. Notice that it's exactly the same. I'm just going to make it now to the second. Now I have to do my chain rule. So now I'm going to start on just the inside. So pretend that this was the original problem. What's the derivative of sine? Cosine. Don't change your argument. And then what's the derivative of the argument? That's just 4. So my final answer, I can multiply that 3 and that 4 together. So I get 12 sine squared of 4x cosine of 4x. Okay, so let me run through this again. I rewrote this to be a cubed out here. Now I just powered down and kept it exactly the same. Don't change what's inside here. Now take the derivative of the trig function, which was cosine, keeping the argument exactly the same. And then I took the derivative of the argument, which was 4. So if there is a 4x in the beginning of the problem, every trig function should have that same argument, and my answers do. All right, people get confused between these two. So I have cosine of 3x squared, and I have cosine squared of 3x. So when I go through here, my first job is I figure out what is the argument. Well, in this first one, my argument is 3x squared. In the second one, my argument is just 3x. The only problem is in that second one, I don't like that squared there, so I'm going to rewrite it like this. Cosine of 3x, the whole thing squared. Okay, so I'm going to take the derivative of both sides here. Derivative of cosine is negative sine. My argument does not change. Now I need the derivative of that argument. Well, the derivative of 3x squared, just power that down, and I get 6x. So my final derivative is negative 6x sine of 3x squared. But on the second one, it's kind of like number 4 from the one we just did. I have to do a couple extra steps. So I'm going to power that down, and I'm going to keep cosine of 3x exactly the same. Just going to make it to the first. Notice I just recopied that exact same thing, and my argument did not change. Derivative of cosine is negative sine. Keeping that argument exactly the same. I did not change the argument. 3x, 3x, 3x. Now take the derivative of 3x, which is 3. So here, my final derivative, I can multiply that 2, the negative 1, and the 3 together. So I get a negative 6 cosine of 3x sine of 3x. So recognize that these two problems are very, very different. And so I would have this problem kind of handy when you're going through the homework so you can decide, well, wait, does it look like this or does it look like this?